Hi, my name is RohitApte and I'm an SCPD student out of Hong Kong. For the final project, I did the SQUAD challenge, machine comprehension on the Stanford question answering dataset. Machine comprehension evaluates a machine's understanding by posing a series of reading comprehension questions and associated text, where the answer to each question can be found only in its associated text. This remains a challenging task for machine learning algorithms. The system has to model complex interactions between the text and the question. Traditional approaches to NLP involve using statistical techniques and a lot of feature engineering. With the availability of large training corpuses, current approach uses deep learning techniques. Deep learning by itself has limitations. For example, using an LSTM to model machine comprehension means the final hidden state has to encode all the information about a long paragraph. This doesn't tend to do so well in practice. Since the release of the SQUAD challenge in 2016, we've seen some significant breakthroughs in machine comprehension accuracy. Most of these models use some form of attention mechanisms. A quick review on the dataset. The SQUAD dataset uses articles sourced from Wikipedia and has over 100,000 questions. The label data was obtained by crowdsourcing on Amazon Turk. There are two accuracy metrics, an exact match and an F1 metric, which is the harmonic mean of precision and recall. For the ground truth, 3 human responses were taken for each answer, and the official evaluation takes the maximum F1 and EM scores for each one. Before I started on the deep learning aspect of the project, I tried to analyze the data to give me an idea of where the answer span lies within the paragraph, question word length, paragraph word length, and so on. This helped me tweak model parameters for my deep learning models. My model was closely based on the bidirectional attention flow paper published in 2016. This is the architectural diagram of my model. My model differs from the original paper in a few ways. For the character encoding layer, I trained my own character vectors on Wikipedia into 50-dimensional vectors. It wasn't clear what the original paper used. If they'd used Google character embeddings, it would have been a 16-dimensional character vector. For the modeling layer, I used 3 layers of bidirectional RNNs. The original paper had 2 layers. In my implementation, the modeling layer feeds to both the start and end state calculations, both of which use a dense layer and a softmax. In the original paper, the end state is calculated differently. The start state feeds to the end state, which uses an LSTM and a softmax layer. Overall, my model achieved an accuracy close to the original BiDAF paper. On the test leaderboard, I scored 76.082 on the F1 metric versus the original paper's results of 77.323. And on the exact match metric, I scored 65.751 versus the original result of 67.947. The difference in accuracy can be attributed to variations in my implementation versus the original paper, and further hyperparameter tuning, which would probably converge the results more. My takeaway from this project is that deep learning techniques coupled with attention mechanisms can achieve high level of accuracy on machine comprehension. Looking at the leaderboards of the official competition, I noticed that model ensembles yield better accuracy, so this would be a good approach to extend my work. Also, there have been recent breakthroughs on the SQUAD challenge that have seen several teams, Microsoft, Alibaba, and others, reach even higher levels of accuracy and beat human level of accuracy on some metrics. This is a partial list of references used for my paper. A more detailed list is available with my official submission.